Welcome to our tutorial on reverse engineering and decompiling Python bytecode. In this session, we will dive into the fascinating world of Python internals, where we will explore how to disassemble bytecode and even recover original source code from PIC files. Whether you're a developer looking to debug your applications or a security enthusiast wanting to understand how to protect your code, this video is designed for you. We'll cover the significance of Python bytecode, introduce the dis module, and guide you through practical techniques for decompiling files. By the end of this video, you'll have a solid understanding of reverse engineering principles and how they can enhance your security practices in Python applications. So let's get started. Before we dive deeper, let's take a moment to understand what Python bytecode is and why it matters. Python bytecode is an intermediate representation of your source code, generated by the Python interpreter. When you run a Python script, it's first compiled into bytecode, which is then executed by the Python virtual machine. This process allows for platform independence and optimization of code execution. Understanding bytecode is crucial for several reasons. It helps in debugging, enhances performance analysis, and is a key aspect of reverse engineering. By learning how to read and manipulate bytecode, you gain insights into Python's inner workings, which can be invaluable for both development and security. Now, let's explore how we can disassemble this bytecode using the dis module. The dis module is a powerful tool that allows us to disassemble Python bytecode into a human-readable format. It provides several functions to inspect the bytecode of Python functions, classes, and modules. Some of the key functionalities include disassembling code objects, inspecting the bytecode instructions, and even analyzing the stack and variable states during execution. To get started, you can simply import the module and use the dis function on a compiled code object. For example, let's take a look at this simple function, def_greet, return hello world. By compiling it and passing it to dis, we can see the bytecode generated. This insight can help us understand how Python executes our code and identify any performance bottlenecks. Let's look at a code example to see this in action. Now let's move on to the practical aspect, decompiling PIC files. These files are compiled Python files that contain bytecode. To decompile them, we can use tools like uncompile6 or decompile3. The process is straightforward. First, install the decompilation tool using pip. Next, run the tool in your command line interface, specifying the path to the PIC file you wish to decompile. The output will be the reconstructed source code, which you can then analyze or modify. Remember, decompiling is a powerful technique, but it's essential to respect copyright and licensing agreements. Always ensure you have permission to decompile code that is not your own. Now, let's see this process in action with a live demonstration. Reconstructing the original Python source code from bytecode can be a challenging task, but there are effective techniques we can employ. First, understanding the structure of Python bytecode is crucial. This includes knowing how functions, classes, and variables are represented. Next, using decompilation tools like uncompile6 can significantly simplify the process, as they attempt to reverse the bytecode back into a more readable format. Additionally, examining the disassembled bytecode using the dis module can provide hints about the original source code's logic and flow. For example, if we disassemble a function and see specific bytecode instructions, we can infer the types of variables used and the control flow. This knowledge is invaluable for debugging and enhancing security practices in your applications. Let's look at a real-world example to illustrate these techniques. Understanding Python bytecode and reverse engineering can have profound implications for debugging and security analysis. For debugging, being able to disassemble your code allows you to trace execution, identify performance issues, and understand unexpected behavior. You can pinpoint the exact bytecode instruction that leads to an error, which can be a game changer in resolving bugs efficiently. Security side, reverse engineering helps identify vulnerabilities in third-party libraries or applications. By analyzing the bytecode, you can uncover hidden logic, potential exploits, and ensure your code adheres to security best practices. Furthermore, being familiar with reverse engineering techniques can empower you to better protect your own applications from malicious actors. As we continue, let's explore some best practices and ethical considerations in reverse engineering. As we delve into reverse engineering, it's crucial to adhere to best practices and ethical considerations. First and foremost, always respect intellectual property rights. Reverse engineering should only be conducted on software you own or have explicit permission to analyze. Understand the legal implications in your jurisdiction, as laws vary widely regarding software decompilation. Additionally, maintain transparency in your actions. If you're working on a project that involves reverse engineering, document your process and findings. This not only helps in maintaining ethical standards, but also aids in knowledge sharing within the development community. Lastly, ensure that your reverse engineering efforts are aimed at improving security, debugging, or enhancing functionality, rather than malicious intent. By following these principles, we can foster a responsible approach to reverse engineering in the software industry. In conclusion, reverse engineering and decompiling Python bytecode opens up a wealth of opportunities for developers and security professionals alike. We've explored the significance of Python bytecode, learned how to use the dis module, and practiced decompiling, pick files. Remember, understanding the inner workings of Python not only enhances your debugging skills, but also fortifies your security practices. For those eager to learn more, I encourage you to explore additional resources such as the official Python documentation, books on Python internals, and online courses focused on security analysis. Thank you for joining me on this journey into the world of reverse engineering. I hope you found this tutorial informative and inspiring. Happy coding!